Hi everyone, welcome to Knowledge Center. In this session, I just want to tell you that I am going to start a very new session wherein I am going to solve the objective type of questions from the textbook which is written by Mehta and Rohit Mehta. Most of the electrical competitive exams questions will be approached by this book. So if you become perfect with this book, then it will be easy for you to crack any kind of an examination. It may be a government or it may be a technical round in the placement duration. Okay, so I suggest you guys to follow my channel, so that you can get all the new updates whenever I upload a new video. So as of now, I am going to start with the DC machines. So they have several number of questions in this textbook according for us DC machines. In this session, I am just taking the first 10 questions. So question number 1 to question number 10 regarding DC machines will be explained here with the solution. So let's begin with the question number 1. So the yoke of a DC machine is made of dash. So this is a very simple question. It has been started with the design of a DC machine. In this DC machine, yoke is a part which is going to provide a mechanical support, and also it will provide a path for a flux to flow. So mechanical support is the major part of this yoke. So mechanically strong, we have to select a material which is strength is very high. In regard in that, if you see silicon steel, soft iron and aluminium will not be considered for that. Cast iron or cast steel will be the material used for yoke, because the cast iron or cast steel will provide a very good mechanical strength to the machine. So option 4 will be the answer for this question. Now question number 2 is about armature. The armature of a DC machine is made of dash. See, the concept of armature is it is going to provide a space for placing a conductors in it. You can look at here, armature will have a slots, and in these slots we will have a copper winding. So the current will be made to flow through that copper winding. Whenever the current is made to flow through that copper winding, it will develop the flux. So it is just providing a space to have a winding in a slot. Means we should not have an eddy current loss in that armature. To reduce that eddy current loss, silicon steel is the material used for development or manufacturing of an armature. So silicon steel will be the best material or a correct option for this question. Here we are not going to use any iron, soft iron or a wrought iron or a cast steel, because using those materials will increase the eddy current loss. So silicon steel, if you use silicon steel, then the eddy current loss will be reduced in the armature. So option 1 will be the answer for the question number 2. Now question number 3 is something like this. The coupling field between electrical and mechanical systems of a DC machine is dash. Okay, so in a DC machine, the coupling is nothing but it will be a magnetic coupling. Flux developed from the pole will be coming in contact with the armature conductors. So that is magnetically, the flux is a magnetic material parameter. So we can say that the magnetic field, it is connected through a magnetic field. Option 2 will be the right answer here. Question number 4 says that the real working part of a DC machine is dash. Okay, so in a DC machine we have all these parameters like commutator, field winding, armature, and the last option is none of the above, but definitely there must be one of the answers here. So last option will be vanished, we can just neglect it. The commutator will convert the output AC into DC, that is the part it is going to do. Field winding will give the field excitation, that is the flux developed, whereas armature winding is the main source where EMF is induced in a DC machine. So we can say the real and actual work has been done in the armature winding. So for this question, option 3 will be the answer. Armature winding is the real working part of DC machine, because if we have that EMF, then only we can convert it into DC using commutator. So armature winding will be a real working part of DC machine. Question number 5 says that dash DC machines are most common. It means they are given some number of poles over there. So which kind of pole, what number of poles are used commonly? So generally we know that we have a relation that n is equal to 120 f by p, where frequency is, standard frequency in India is of 50 hertz, and if you take 50 hertz here, so 120 into 50, it will be 6000 by p, and the standard speed what we have will be of 1500 rpm. So we can select number of poles as 4. So 4 pole will be a common for DC machines. Construction wise is also easy, and also it is going to develop 1500 rpm using that 4 pole machine. Okay, so option B, that is option 2, will be the answer for this question. The armature winding of a DC machine is placed on the rotor to dash. Okay, so most of the concept here is, in a DC machine, the armature winding is used as a rotor. So what is the reason for that? That's the question here. So the options are save iron, reduce losses, facilitate commutation, reduce armature reaction. See here, you can look into the picture. We have commutators in the DC machines. This commutator, what it is going to do is, it is going to convert that AC to DC, and this commutator is rotating part. Okay, so the armature EMF is induced in the armature, and that armature voltage is alternative. That alternative voltage has to be connected to the commutator, then only it will be converting it into DC. As commutator is rotating, our armature should also be a rotating part. So armature is used as a rotor, so that it can be connected to a commutator which is rotating and converting it into DC. So for this question, the option is armature is made as a rotor to facilitate commutation. If armature is static, then that cannot be connected to the commutator. Okay, so that is the reason why we are making that armature as a rotor in a DC machine, to facilitate commutation. Option 3 will be the answer. Okay, this question number 7 is about yoke. The yoke of a DC machine carries dash pole flux. Okay, so yoke of DC machine carries dash pole flux. If you consider 2 pole, here look at the picture, 2 pole, and the total flux is 5. Then half of the flux will be in this direction, in this pole yoke and pole path, and remaining half of the flux will be in this portion. So among the total flux, the flux will be divided into 2 here. Half of the flux will be flowing in this direction, and half of the flux will be flowing in the opposite direction. So we can say the yoke of DC machine carries 1/2 of the pole flux. Half of this pole flux will be carried in the yoke. So option 2 will be the answer for this, 1/2 of the pole flux. Question number 8 is, a 4-pole DC machine has dash magnetic circuits. Okay, look at this picture here. There are 4 poles, 1, 2, 3 and 4. The flux will be flowing like this from one pole to other pole, and this path where the flux is flowing, we call it as a magnetic circuit. So if we have a 4 poles, we can have 4 combinations like this. So we can say 4 magnetic circuits will be the answer for this question. A 4-pole DC machine will have a 4 magnetic circuits. Option 3 will be the answer for this question. Now question number 9 is, the field structure of a DC machine uses dash. So there are 2 type of a structure for a DC machine, that is the salient pole construction and the non-salient pole construction. So salient pole construction is generally used for a field winding, so to place the field winding. Here when we place the field winding here, there will be a pole shoe which is protecting that winding. Okay, so and also the cast iron material used here will be less compared to the material used here. The weight of the non-salient pole construction will be huge, so instead of that they go for a salient pole construction, so that the weight of the machine will also be reduced. So option for this question will be the salient pole arrangement. First option will be the answer for this question. Now let's move on for the last question for the today's session, that is, the small DC machines generally have dash poles. Small DC machine name itself indicates the machine is small, so the number of poles which we use over there has to be less. So 2 will be the option for this. Option 3 will be the answer for this question. I hope it is clear for you guys and you are enjoying this session. In next video I will continue with the question number 11. So meanwhile, similarly I will just complete the DC machine. After DC machine we will go for the next topic. If you subscribe to my channel, you will get the notification of all the new videos. I kindly request you to subscribe to my channel and also share among your friends so that the knowledge can be shared with all. Thank you.